What if I told you there's an engine that ran for 72 hours straight at full throttle, consumed fuel like it was going out of style, and still embarrassed every hot rod that dared challenge it? This isn't some fairy tale about racing glory. This is the story of how a diesel engine designed to move tanks became the most unlikely dominator in American motorsports history. Nan, picture this. It's 1962, and you're standing trackside at the inaugural 24 Hours of Daytona. The air is thick with high-octane fumes and testosterone. Million-dollar Ferraris growl past. Lightweight Corvettes scream down the banking. British Jaguars purr with refined menace. Then you hear it, a deep guttural rumble that sounds like someone brought a bulldozer to a ballet. That sound? That's a Detroit diesel 6V53 about to teach everyone a lesson in what real endurance means. And then, this is the story of how military spec engineering humiliated the racing establishment, how an engine built to survive World War III outlasted, outran, and outthought every purpose-built race motor on the circuit, and how American hot rodders learned the hard way that sometimes boring beats beautiful. And then to understand why a diesel engine ended up racing against Ferraris, we need to travel back to 1938. Detroit Diesel, then a division of General Motors, wasn't thinking about checkered flags. They were thinking about something far more serious, keeping America's military machinery moving no matter what. The world was sliding toward war, and the military needed engines that could survive anything. Desert sand, Arctic cold, jungle humidity, direct hits from enemy fire. Nene. The engineering brief was simple but brutal. Create an engine that could run for days without stopping. Make it repairable with a hammer and basic tools. Design it to burn any fuel from refined diesel to filtered cooking oil. And most importantly, make it absolutely, completely, totally unbreakable. What emerged from Detroit's engineering labs wasn't pretty. The 6V53 was a two-stroke diesel that looked like it belonged in a factory, not on a racetrack. 6 cylinders arranged in a V configuration. 318 cubic inches of displacement. In naturally aspirated form, it produced a modest 180 horsepower at 2,800 RPM. Hot rodders of the era would have laughed. A small block Chevy could make more power with a mild cam and a 4-barrel carburetor. But here's where it gets interesting. The 6V53 wasn't designed to win drag races. It was designed to win wars. Every component was overbuilt to military specification. The block was cast from high nickel iron alloy that could handle pressure spikes that would crack a racing block like an egg. The crankshaft was forged from 4140 chromoly steel, nitrided for surface hardness, and balanced to tolerances that made Swiss watchmakers jealous. Each connecting rod was shot-peened, magnafluxed, and rated for continuous operation at maximum load. The head design was revolutionary for its simplicity. 4 valves per cylinder, all exhaust. Wait, what? That's right. Being a 2-stroke diesel, the 6V53 didn't need intake valves. Fresh air entered through ports in the cylinder walls, blown in by a gear-driven root supercharger that wasn't there for performance. It was there because the engine literally couldn't run without it. This blower, designated 6V53, moved 159 cubic feet of air per minute at rated speed, not for boost, just to make the engine function. In the injection system was pure Detroit diesel genius. Individual unit injectors for each cylinder, mechanically operated by a dedicated camshaft. Each injector was a self-contained pump, nozzle, and metering system. Fuel pressure at the injector tip reached 26,000 psi. That's enough pressure to cut through human flesh like a laser. The injectors fired every revolution, not every other revolution like a 4-stroke. This meant the 6V53 produced twice as many power strokes as a conventional engine at the same RPM. Now, here's the kicker. In 1961, a small racing team in Florida had a crazy idea. They'd been hired to prepare a car for the new 24-hour endurance race at Daytona. Everyone else was focused on speed. These guys focused on survival. They remembered something most racers forgot. To finish first you must finish. The team, led by engineer Bill France Jr., yes, that Bill France, looked at the statistics from European endurance racing. The attrition rate was brutal. At Le Mans, only 40% of starters typically saw the checkered flag. Engines failed. Transmissions exploded. Cooling systems gave up. The faster the engine, the more likely it was to grenade itself during hour 15 of a 24-hour thrash. Then France and his team made a radical decision. Forget horsepower. Focus on torque and reliability. They acquired a military surplus 6 V53T, the turbocharged variant rated at 275 horsepower and 520 pound-feet of torque. By racing standards, those numbers were pathetic. A contemporary Ford 427 made 425 horsepower. The Ferrari 250 GTO's V12 produced 300 horsepower from half the displacement d'Autonne, but the 6V53T had something those engines didn't. Military-grade durability ratings that were frankly absurd. Continuous duty rating, 2100 RPM for 10,000 hours between overhauls. Peak torque available from 1200 RPM. Oil change intervals, 500 hours. Time between major failures, essentially infinite if properly maintained. The military specification sheets, document MIL DTL 2104H if you want to look it up, required the engine to survive submersion, extreme shock loading equivalent to a 10G impact, and temperature swings from -60 to +140 degrees Fahrenheit. Engines. The team installed this diesel lump into a modified Pontiac Tempest chassis. The car looked ridiculous next to the sleek sports cars. It weighed 4,200 pounds, nearly a ton more than the Ferraris. The exhaust note was agricultural. At idle, it sounded like a city bus. Under load, it bellowed black smoke like a freight train. In an end practice day, was humiliating. The diesel Pontiac was 15 seconds per lap, slower than the leaders. On Daytona's high banks, Ferraris passed it like it was standing still. In the infield sections, Corvettes left it for dead. The pit lane erupted in laughter when the diesel car trundled past, trailing soot and shame. But then, the green flag dropped for the race. 1 hour 1. The diesel maintained a steady pace while others charged hard. 1 hour 3. The first Ferrari retired with a blown head gasket. An hour 6. 2 Corvettes out with transmission failures. An hour 12. As midnight approached, half the field had retired. The diesel Pontiac just kept circulating. The engine temperature never budged from 180 degrees. Oil pressure remained rock solid at 45 psi. Fuel consumption was atrocious, 8 miles per gallon at race pace. But who cared? The thing simply would not break. The torture test continued through the night. While other teams performed emergency engine swaps, the diesel crew changed tires and added fuel. That's it. No adjustments needed. No parts replaced. The engine note never changed. The same steady rumble, hour after hour. By dawn, something extraordinary was happening. The diesel Pontiac had climbed to 5th place, not through speed, but through attrition. Faster cars kept braking. The diesel kept running. It had turned into a mechanical metaphor for the tortoise and the hare, played out at 100 miles per hour. Let me explain what was happening inside that engine that made it so indestructible. The 6V53's two-stroke design meant lower peak cylinder pressures than a 4-stroke. Instead of one massive explosion every other revolution, it had smaller, more frequent power pulses. This reduced stress on every component. The connecting rod bearing loads peaked at 4,200 psi compared to over 8,000 psi in a high-performance 4-stroke, and the cooling system was massively overbuilt. The water pump moved 90 gallons per minute, enough to fill a bathtub in 2 minutes. The radiator core was sized for desert combat conditions. It could reject 250,000 BTUs per hour. In racing terms, that meant the engine could run flat out in 100-degree weather without overheating. The lubrication system was even more impressive. Dual oil pumps, one pressure, one scavenging, circulated 15 gallons per minute through galleries large enough to stick your finger in. The oil cooler, military part number 5579991, was rated for continuous operation at 300 degrees. Racing engines of the era typically ran 10W40 oil. The Detroit ran 30W straight weight, specified as MILL2104C, which maintained viscosity even when contaminated with fuel or coolant, but the real secret weapon was the governor. While racing engines relied on driver skill to avoid over-revving, the 6V53 had a mechanical governor that absolutely would not allow the engine to exceed 2,800 RPM, period. You could stand on the throttle all day. The governor didn't care. It would hold exactly 2,800 RPM, protecting the engine from the #1 killer in endurance racing, driver error. Back at Daytona, hour 18 arrived with a shock. The diesel Pontiac had moved into second place. The Ferrari leading the race was starting to slow, its engine beginning to smoke. The impossible was becoming possible. A diesel engine, a tank motor, was about to win a major sports car race. And the Ferrari team made a desperate decision. They would push harder, try to build an insurmountable lead before their engine expired. It was a suicide run. The Ferrari driver, veteran racer Pedro Rodriguez, later said, I could hear death in my engine, but what choice did I have? That diesel thing just kept coming, like a zombie that wouldn't die. Hour 20. The Ferrari's engine let go in spectacular fashion, coating the back straight with oil and ending in a cloud of expensive Italian smoke. The diesel Pontiac inherited the lead. The crowd was stunned. The announcers didn't know what to say. A diesel was winning at Daytona. The final 4 hours were surreal. The diesel car circulated with mechanical precision. Lap times varied by less than 2 seconds. Fuel stops every 90 minutes. Tire changes every 3 hours. The crew chief later revealed their strategy. We ran it exactly like you'd run a generator. Steady load, steady speed, proper maintenance intervals. We treated it like an industrial application that happened to be on a racetrack. When the checkered flag fell after 24 hours, the diesel Pontiac had covered 2,224 miles at an average speed of 88.5 miles per hour. It finished 37 laps ahead of the second-place Corvette. Of the 65 cars that started, only 19 finished. The diesel had beaten them all. The racing world was in shock. How could this happen? How could a slow, heavy agricultural diesel engine defeat purpose-built racing machinery? The answer lay in the fundamental philosophy difference between military and racing engineering. Racing engines were designed to produce maximum power for minimum weight. They operated at the edge of destruction. Military engines were designed to produce adequate power indefinitely. They operated in the center of their performance envelope. Let's talk specific numbers that explain this victory. The 6V53T at Daytona ran at an average of 2,100 RPM during the race. Its maximum rated speed was 2,800 RPM. It was operating at 75% capacity. The Ferrari V12 that failed, it averaged 6,500 RPM against a red line of 7,500 RPM, operating at 87% capacity. Those 12 percentage points made all the difference over 24 hours. And thermal efficiency told the same story. The diesel ran at 38% thermal efficiency, meaning 38% of the fuel's energy became mechanical work. The gasoline engines averaged 25% efficiency. Sure, the diesel burned more fuel per mile, but it extracted more work from every gallon. Over 24 hours, that efficiency advantage compounded. And the turbocharger on the 6V53T was particularly clever. It wasn't a high-performance unit designed for maximum boost. It was a Schweitzer 3LM319, originally designed for stationary power generation. It produced a modest 8 psi of boost, but it did so with incredible consistency. The turbine housing was sized for continuous operation at 85,000 RPM. Racing turbos of the era often exceeded 120,000 RPM and had a nasty habit of exploding, and just after Daytona, other teams took notice. Could military diesel technology be the secret to endurance racing success? Several teams began experimenting. In 1963, a Cummins NHC 250 powered car entered at Sebring. In 1964, a Caterpillar 3208 diesel competed at Le Mans. But none captured the magic of that original diesel Pontiac. And why? Because they missed the point. It wasn't just about using a diesel, it was about understanding that endurance racing rewarded different qualities than sprint racing. The team that won at Daytona didn't try to make their diesel faster. They accepted its limitations and exploited its strengths. And the legacy of this unlikely victory rippled through motorsports. Within 5 years, turbocharged engines became common in endurance racing. The concept of derating engines for reliability became standard practice. The idea that torque mattered as much as horsepower gained acceptance. But the most lasting impact was philosophical. That diesel victory proved that there's more than one way to win a race. Sometimes the smartest move isn't to go faster, it's to keep going when everyone else stops. And in the Detroit Diesel 6V53 itself became a legend. Originally designed in 1957, it remained in production until 1995. Over 2 million units were built. You'll find them in everything from city buses to fishing boats to emergency generators. Many are still running today, 6 decades after that famous Daytona victory, still refusing to die. The specific engine that won at Daytona? It was removed from the race car and installed in a municipal water pumping station in Jacksonville, Florida. It ran there for another 30 years, pumping millions of gallons of water before finally being retired to the Florida Museum of Speed. When they tore it down for display, the technicians were amazed. The cylinder bores still showed the original crosshatch honing marks. The bearing clearances were still within factory specifications. After 24 hours of racing and 30 years of pumping, it could have been rebuilt and run another lifetime. The hot rod community learned valuable lessons from this diesel embarrassment. They began incorporating military spec components into their builds. Forged internals became standard. Oil cooling systems grew larger. The philosophy shifted from bar maximum power to bar maximum sustainable power. And today's endurance racing engines are essentially high-performance versions of that original diesel philosophy. The Audi R18 TDI that dominated Le Mans used a turbocharged diesel V6. Modern LMP1 cars use hybrid systems that prioritize efficiency over raw power. The lessons from 1962 echo in every pit lane. But perhaps the greatest lesson is this. Engineering isn't just about making things faster or more powerful. It's about understanding the problem you're trying to solve. Those Detroit diesel engineers in 1938 weren't trying to build a race engine. They were trying to build an engine that would never let a soldier down, that would start in a blizzard, that would run on contaminated fuel, that would survive being shot at on. They succeeded so completely that their creation could beat purpose-built race cars simply by refusing to break. It's a reminder that sometimes the best engineering isn't the most sophisticated or the most powerful. Sometimes it's simply the most thoughtful. The story of the diesel that beat the hot rods isn't really about engines at all. It's about hubris and humility. It's about the racing establishment learning that speed without endurance is meaningless. It's about a group of engineers who understood that in any real test of machinery, the one that finishes is better than the one that's fastest. Our modern world of planned obsolescence and race-to-the-bottom manufacturing, there's something deeply satisfying about an engine designed to last forever. The 6V53 was built in an era when engineers asked Haas, how long can we make this last? Instead of Bost, how little material can we use? The result was a machine that could humble million-dollar race cars while being simple enough to fix with hand tools. And every time I hear some young hot rodder bragging about their built motor making 800 horsepower, I want to ask them a simple question. Can it run for 24 hours straight? Can it do it again tomorrow and the day after that? Because somewhere in a pump house or a generator room or the engine bay of an old military truck, there's a Detroit diesel 6V53 that's been running since before that hot rodder was born. And it'll still be running long after their race motor has turned to scrap to none. That's the ultimate victory, not winning one race, but outlasting everything else on the road. The diesel that won at Daytona didn't just beat the hot rods for 24 hours. In a very real sense, it's still beating them today, every time one of these indestructible engines fires up and goes to work. The engineers who designed the 6V53 probably never imagined it would win races. They were focused on a different kind of victory, the victory of reliability over performance, of function over form, of getting the job done over looking good doing it. But in creating an engine that simply would not quit, they accidentally created a racing legend. So the next time you hear a diesel rumbling down the street, maybe in a delivery truck or a piece of construction equipment, remember that you're listening to the same basic technology that once humiliated the fastest cars in the world. Not through speed or sophistication, but through sheer unstoppable military-grade determination to keep running no matter what. And that's engineering, that's endurance. That's the story of how one Detroit diesel tank engine outsmarted every hot rod with military hardware. And if that doesn't make you appreciate the beauty of overbuilt, understressed military spec engineering, then you're missing one of the great stories in American motorsports history. What's the most unlikely racing victory you've ever witnessed? Drop a comment below and let me know. And if you enjoyed this deep dive into diesel domination, make sure to subscribe for more stories of engineering underdogs that change the game. Until next time, keep those engines running, whether they're gas, diesel, or something else entirely.